The panic headlines claim AI is coming for your job, but they are ignoring the most expensive component in the room, the chip. While LLMs can write a function or generate a test case in seconds, running them autonomously on complex systems hits an immediate wall called inference cost. A single full-stack project does not just require code, it requires massive GPU and TPU cycles that cost thousands of dollars to run without human oversight. The reality is not replacement but a shift from being a code writer to the architect of expensive compute. You are not obsolete because you can write loops faster than an AI, but you are essential because no current hardware allows an agent to manage full-stack complexity economically or reliably on its own. For years, the narrative has been that artificial intelligence will eventually automate every line of software development. This fear is understandable given how quickly generative models have improved at writing syntax and generating boilerplate code. However, this perspective assumes that intelligence alone is the barrier to entry for full autonomy. It overlooks a fundamental physical constraint, the economic ceiling imposed by current hardware architecture. When we look at what actually happens when teams attempt to deploy autonomous agents on complex systems, the bottleneck becomes clear immediately. Gartner analysis from 2024 confirms that fully autonomous execution remains economically unviable for non-trivial projects. The issue is not whether the model knows how to solve a problem, it is whether running the computation required to solve it without human intervention costs less than paying an engineer. Current hardware, specifically GPUs and TPUs designed for massive parallel processing, creates a unique economic reality. An AI agent attempting to debug or build a complex system must generate thousands of inference calls. Each call consumes compute power that translates directly into dollars on your cloud bill. Without a human in the loop to prune unnecessary queries or optimize the path forward, the cost escalates exponentially and quickly becomes unsustainable compared to a skilled engineer who knows exactly what code is needed. This creates a hard economic wall where full autonomy simply cannot compete with human efficiency for complex tasks. The value of an engineer today is no longer just writing lines. It is acting as the budget manager for these expensive resources, ensuring that every dollar spent on compute yields a reliable result rather than burning through credits in endless trial and error loops. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This shift forces us to reconsider what we mean by software development work. We are moving from deterministic programming, where an engineer writes specific instructions line by line, toward agentic engineering, which involves governing probabilistic systems. Research into this transition highlights that while AI accelerates specific tasks significantly, with studies showing developers can write new code nearly 50% faster with generative assistance, it introduces behaviors like drift and hallucination that machines cannot self-correct without human judgment. The core value of the engineer is now in overseeing these statistical outcomes to ensure they meet business requirements rather than just checking for syntax errors. If an agent makes a subtle error in logic, it can propagate through the system until failure occurs downstream, costing far more in debugging time and lost revenue than the initial savings from automation would ever provide. The limitations of current hardware become even more apparent when we look at specialized engineering challenges like parallel signal flows or complex circuit interactions. A critical study using the Phoenix Bench benchmark tested whether AI agents could handle real-world hardware tasks comparable to software debugging, and the results were stark. When applied to these complex environments where bugs propagate through parallel circuits rather than sequential call graphs, software-tuned agents suffered a 37% to 58% drop in success rates compared to human experts. The study found that simply providing an agent with the perfect file location improved results by only 1.4%. It was the inclusion of execution logs and test bench feedback, a form of debugging intuition, that lifted success rates by over 45%. This proves that current hardware cannot yet support fully autonomous repair or design without a human in the loop to interpret failure signals and guide the agent through the nuances of physical constraints. This data fundamentally changes how we view career relevance for developers at all levels. Data from community discussions indicates that 75% of developers are already using AI tools, not as replacements but as assistive partners. The role is evolving into agentic engineering, where accountability shifts from authoring code lines to owning system outcomes. For junior engineers, the entry-level task of writing basic code is indeed being automated, which might seem alarming at first glance. However, this does not mean they can leave. It means they must pivot immediately to understanding system architecture and how to direct AI agents effectively. The barrier to entry for autonomous work remains high due to cost, meaning the human who knows where to spend that compute budget becomes more valuable than ever before. For senior engineers, the role is shifting from fixing bugs to designing oversight systems. You are now responsible for the economic efficiency of AI workflows and managing the risks associated with probabilistic outputs like hallucinations or behavioral drifts. The hardware reality ensures you will remain essential as long as complex systems require human judgment to justify the cost of execution. Senior engineers become critical for balancing financial constraints against innovation needs, deciding when an autonomous agent is worth running versus when a manual review is cheaper and safer. This transition from writer to architect means that your ability to orchestrate these expensive chips becomes your primary skill set, far more so than your speed at typing syntax or memorizing library functions. The bottom line for anyone anxious about their future in tech is clear. Do not fear replacement, embrace the transition. The engineers who survive and thrive are those who stop trying to outcode the AI on speed and start mastering it as a resource they manage, rather than just a tool they use. Your value is now defined by your ability to navigate probabilistic systems and optimize expensive compute resources in ways that current machines cannot do alone. By focusing on system design, cost optimization, and oversight of agentic workflows, you position yourself not as obsolete but as the essential operator of the new digital infrastructure. The future belongs to those who can make the hardware work for them without burning through their budget or compromising reliability. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.